So welcome to another segment as we talk about air and non-metals. So we are talking about separating gases from the air. Now, as you know, air is a mixture. We simply say that it is a mixture of gases, and most of the gases that are found in air are very useful to us. So we must separate them from each other. But the question that one may have is, how can we separate these gases that are found in air, because it is a mixture of gases? Well, there's a clever way of actually doing it. So what happens is that first, let me just give you a quick overview. You're going to find that first the air is cooled. So the air is cooled until it turns into a liquid. So that is the first step that they are going to do. You cool the air until it is turned into a liquid. Then the second one is that the liquid mixture. So then the liquid mixture is separated using a method called fractional distillation. So then the liquid mixture is separated using a method called fractional distillation. So fractional distillation is a method that we use to separate liquid air. So initially it is going to be cooled until it becomes a liquid. Then the liquid mixture containing those gases, it is now going to be separated using fractional distillation. Now, why use fractional distillation? What makes fractional distillation workable when it comes to separating gases from the air? Well, the method works because remember that the various gases that are found in air have got different boiling points. So this fractional distillation is based on the property that different substances have got different boiling point. So I can say maybe that the method, we can say that the method works because the gases in air have different boiling, so they have got different boiling points. So that's the key to using fractional distillation, because they have different boiling point. Okay, so when the liquid air is again warmed up, the gases boil at different temperatures, and then they can be collected one at a time. So it is cooled. So again, it is going to be warmed up. So as the gases boil up again, at different temperatures, then the gases can be collected one at a time. So I want to show you the exact apparatus that you may find that they can use. So I've actually drawn something there so that you are able to see. So this is a kind of an apparatus that is going to be used during fractional distillation of liquid air. So you're going to find, I'll just run you through so that you are able to see, how, liquid air is actually separated into different gases. Initially, what is going to happen there is that, air from the atmosphere is going to be drawn in. So air is going to be drawn in, there's actually a pump that will be there that is going to pump the air into, an industry. But of course, before air can be, once it is drawn from the atmosphere, it needs to be filtered. So somewhere here, there's going to be a filter. And what does that filter do? Well, that filter, the filter that we have there, the filter that we have at that point is going to, to help remove, so that filter is going to help to remove, any dust particles that may be found in the air. So that is the purpose of the filter, to remove any dust particles that are going to be there. Then the next thing that is going to happen in stage number 2, you are going to find that carbon dioxide and also water vapor. So let me say water vapor there. So carbon dioxide and water vapor are going to be removed. So that's the thing. So any pollutant, water vapor and carbon dioxide are removed. The reason is very simple. You know, carbon dioxide and water vapor may freeze and later, you know, block the pipe. So we do not want that to happen. So initially, once the air is filtered, the carbon dioxide and the water vapor, and together with other impurities that may be there, are going to be removed. Now, how is that done? Well, first of all, you know, the air is actually cooled until the water vapor condenses to water. Then what is going to happen is that it is passed over, you know, beds of absorbent, you know, beads to trap, you know, carbon dioxide and any pollutant in it. So that is how, you know, we get rid of it. The next step that is going to take place is that now the air, after being cleaned, carbon dioxide and water being removed, it is now going to be forced into a small space. In simple terms, we mean it is going to be compressed. It is going to be compressed. So in stage number 3 here that you see, you are going to find that the air will now be compressed. So you are going to find that the air is now going to be compressed, and you know, then it is going to be cooled. So it will be compressed and then it is going to be cooled. Now remember, what happens is that when the air is actually, you know, compressed or forced into a small space, that makes it hot. So it is cooled down again by recycling air. So this is what you are able to see. It is going to be cooled by, you know, recycling cold air, as you can see from the diagram. So in this section here, you are going to find that you know, air is actually going to be, you know, expanded. So as it is expanded, you know, it gets very cold. So initially it was you know, cooled. So what is going to happen when it is taken into a larger space? It starts to expand. So when it is expanded, it gets very cold, and after several cycles it will liquefy, and that is why you can see, so the cycle will be repeated so many times. So when it is repeated so many times, then it is going to be liquefied. So like I said, in stage number 4, you are going to find that the cold and compressed air is passed you know, through a jet into, so it is going to be passed, you can see this stuff that we have there, so it is going to be passed through a jet into a larger space. So when it is passed into a larger space from this compartment where it was compressed and cooled, what is going to happen now is that it expands rapidly because it is in a bigger space, and this makes it very cold. So it can actually, you know, be recycled several times. So once it is done like that, at the bottom there, now what is going to be collected at the bottom there, you are going to find that you know, it is going to be liquefied. So you are going to have liquid, you know, air at approximately maybe -200 degrees Celsius. So that is what is going to happen. So it may become very cold, liquefied to a temperature of below, in this case, -200 degrees Celsius. Like I said, you know, step 3 and 4, where the air is compressed and then cooled, stage 3 and 4 is repeated several times. So when it is repeated several times, the air gets colder each time, and hence the temperature of the air is going to reduce, and as it reduces, it changes into a liquid at -200 degrees Celsius. The next step that is going to happen is that the liquid air at that point is now going to be pumped into the fractionating column. So what you see here is what we are calling as being a fractional. So that is a fractionating column. All right. So in the fractionating column, as you know, again, what is at the bottom that I've actually shaded, this is simply representing liquid air, the liquid air, but that liquid air is slowly, you know, warmed up. So it is now going to be warmed up. Remember what I said in my preamble, so it will slowly be warmed up. As a result, you know, as it is warmed up, the gases are going to start, you know, boiling off. So they'll boil off one by one, and they are collected in tanks or cylinders. Now, which one will be the first one that is going to be collected in the fractionating column? Well, nitrogen boils off first. That is what we know. So nitrogen is going to boil off first. Now, why is it that nitrogen is going to boil off first? It is because when you look at the one with the lowest boiling point will distill from the top, and in this case, we are talking about nitrogen somewhere there is going to distill off. So what we are going to have in this case is that on top there you are going to have nitrogen. So that is going to be nitrogen is going to be collected first at the top, and the boiling point is approximately -196 degrees Celsius. It is going to be followed by a gas we are calling as being argon. Argon has a boiling point of about -186, so it has about 186 degrees Celsius. Then it is going to be followed by oxygen. So oxygen is the one that is going to distill out, and approximately the boiling point of oxygen is about 183 degrees Celsius. From there you may have gases like krypton. Krypton has got the boiling point of -153 degrees Celsius, and the least maybe that is going to be collected is xenon. So xenon has a boiling point of -108 degrees Celsius. So you can see how the gases are going to be collected in the fractionating column. So the one with the lowest boiling point will distill out first. So the first one to come out will be nitrogen, followed by argon, oxygen, krypton, and xenon, according to the boiling points that they have. So this is what is going to happen. But I want to quickly give you the boiling points of gases in air. Some of the boiling point of gases in air. We do have carbon dioxide, which is at -32 degrees Celsius. That's the BP, the boiling point. We also have xenon, which is about -108 degrees Celsius. We do have krypton. Krypton, like I said, which is about -153 degrees Celsius. We do have oxygen. Oxygen, the boiling point is about -183 degrees Celsius. And argon, okay, so you can also have argon, which is the boiling point -186 degrees Celsius. You do have what we call as being nitrogen. Nitrogen has got a boiling point of -196 degrees Celsius. You may also have neon and helium. It is possible neon and helium. Neon is about -246 degrees Celsius. Helium is about -269 degrees Celsius. So these are some of the boiling points of the gases that are found in air. So you can still remember that. But briefly, we can simply talk about what are the uses. So we can simply talk about what are the uses of some of these gases, because in an exam they are going to ask you. Remember, in my previous video I did talk about preparation of oxygen, and that is the way oxygen is actually produced in industry. So this is an industrial way of producing oxygen as well. So we use fractional distillation. So let's start with some of the gases that you may encounter that may actually come out from there. Of course, though we have not mentioned hydrogen, hydrogen may actually, is also one of the components of air. So I can just give you the uses of hydrogen, because we know it is one of the components that is found in air. So hydrogen gas. What are the uses of hydrogen gas? So you need to remember that when it comes to hydrogen gas, one, it is actually used in the manufacturing. So hydrogen gas can be used in the manufacturing of ammonia. So it can be used in the manufacturing of ammonia in the Haber process. So if you didn't look at my videos on the Haber process, please, you can look at that. It is used in the manufacture. So we can also say it is used in the manufacture of margarine, margarine from vegetable from vegetable oil. So it is going to be used to convert vegetable oil into margarine. Of course, in a process that we simply call as being hydrogenation. So there's a process that we simply call as being, hydrogenation, the addition of hydrogen to a substance. Of course, there's a catalyst. In this case, normally the catalyst that we use during hydrogenation is what we call as being nickel. You are going to learn later on about that under organic chemistry. Another use of hydrogen is that it is used as a reducing agent. So it is used, as a reducing, so we can say as a reducing agent, a very good, reducing agent. Of course, another use that we can talk about is that when we talk about, liquid, hydrogen. So liquid hydrogen, is used as a fuel. So you can also use it as a fuel in rockets. So you can use it as a fuel in rockets. In fact, it is actually, a good fuel in that it is not a pollutant, or it does not pollute the air. So that is what you need to remember. So it is, environmental, friendly, as we can call it. All right. Another use that we can talk about is what we are calling as being oxygen. What are the uses of oxygen gas? There are so many uses, so I'm just going to give you maybe a few uses of what we are calling as being oxygen gas. Number one, we can say that it is used, in the manufacture. So it is used in the manufacture of steel. It is used in the manufacture of steel, when it is produced from the blast furnace. Two, we can say that, it is used, for welding. So it is used for welding, in the oxacetylene. So oxacetylene, flame. So that is what is going to happen. Another use that we can talk about is that it is used, by deep sea divers. So those that go deep down in the sea, and also we can say mountain climbers. So those that go to the top of the mountain, Mount Kilimanjaro, they need to take what we call oxygen tanks in order for them to survive. All right, let me give you some more uses that we can talk about, for oxygen. Again, oxygen, it is used as a fuel. So it is used as a fuel in rockets. Yeah, so in this case, when hydrogen burns with oxygen, they produce H2O, and that is going to be used as a fuel. So it's a clean fuel, again, that is going to be used. Another one that maybe you can talk about is that, oxygen is used in oxygen tanks. So we can say used in oxygen is what we call oxygen tanks. Yeah, and we can say maybe oxygen tents in hospitals. So there are people that may have breathing difficulties, so they may actually assist them by using oxygen tank or an oxygen tent, so to say, so that they can actually help them, to breathe, especially those individuals in hospitals that are in intensive care units, so they can actually get to use the oxygen. Yeah, so oxygen tanks, or we can call them tanks, but if you want, you can also talk about oxygen masks. Sometimes a person, because they are failing to breathe, they'll give them a mask so that it can actually get to assist them to breathe. All right, let's look at another use of the gases that we have talked about, which they're going to ask you in the exam. Maybe I can focus on maybe uses of nitrogen. What are the uses of nitrogen gas? Well, nitrogen gas has got so many uses that we can talk about. Among the uses that we can talk about is that nitrogen, like we said, is very cold. It boils at -196. So it is used to quick freeze food in food factories. So we can say it is used you know, to quick, you know, freeze food in food factories. So that is what they are going to do. So quickly they can freeze, you know, foods in factories, especially when they want to transport them over a long distance. Apart from that, we can simply say used, you know, to freeze liquids, to freeze, let me say, used to freeze liquids in cracked, you know, pipes before repairing them. Yeah. So if the pipe is actually cracked, what they are going to do is that they are going to, you know, if this is a pipe and water maybe passes in that direction, they may freeze this side and they may freeze that side, so that the liquid, once it becomes frozen, they'll cut this pipe and repair the damage that is there. Then they are going to unfreeze it so that water can continue to pass. Another use of nitrogen is that it is used in hospitals to store, you know, tissue samples. So we can say used in hospitals. So it is also used in hospitals, you know, to store, you know, tissue samples, including sperms. They are what they call as being sperm banks. So they can actually use nitrogen in order to freeze the sperms and later on to be used. All right, let me give you the last one. There are so many uses that you can talk about. Because nitrogen is very unreactive, because of it being unreactive. So let me say that nitrogen is unreactive. So it is also unreactive because of the triple bonds that it has. So because of it being unreactive, you know, it is, we can say it is used, you know, to flush through, you know, food package. So it can be used to flush food packages, you know, to remove oxygen. Yeah, so remember, we don't want it to go bad, so we want to you know, flush out you know, the oxygen. So because nitrogen is unreactive, nitrogen is used to flush through food packages to remove oxygen and you know, keep the food, you know, fresh. So that is what is going to happen. Remember, oxygen helps in the decay of food. So remember that you know, oxygen helps, you know, decay to actually take place. So we don't want that, so we can use nitrogen, you know, to flush out that. All right, let me focus now on the last thing that you need to know. Maybe we can talk about the uses of some noble gases. So uses of noble gases. Noble gases are those gases that are found in group O of your periodic table, and the noble gases, as we know, are unreactive or inert, and that leads them to so many uses. For example, you can talk about neon. What is the use of neon? Neon is used in advertisement. So we use it in advertising signs. Yeah, so we can use it in advertising signs because it glows, you know, red when a current is passed through it. Another use that we can talk about is helium. Helium is used, you know, to fuel. So it is used to fuel, you know, balloons. So that is what we know, since it is very light and actually safe. Then last but not the least, we can talk about argon. So argon provides an inert atmosphere in ordinary